Okay, so last day. I think we're going to be able to do this with just the examples. So we've talked about rotating solids. We talked about if it's a donut with a donut hole, you do the outside of the donut minus the inside of the donut. I lost count of these. Maybe that's enough. So these are examples. I don't know if we'll do all of them or not. Should be right. That's Caleb's. Okay, so what we are talking about today, this is the last of it. Everything that we have done, the graph has been rotated around the x or the y axis. Okay, now we're going to talk about what if it's not the x or the y axis. Okay, so there's not really a name for this, but I'm going to call it non-axis rotations.
Goop axis.
Okay. Yes, Mason?
We've been using their book in a long time. Can we just turn it in?
Yeah. How about Thursday? Okay.
How about goop?
So it says R is the region enclosed by the line x equals -4. The line y equals 1, the line y equals 4, and the curve e to the x. So let's graph y equals e to the x. We should be able to do this one without our calculator, by the way. Graphing it at least. Okay, so y equals e to the x. That's the first thing I'm drawing. Looks like this. We've got the line y equals 1. Hang on.
So y equals 1 straight horizontal.
Yep, I'm just thinking. I was reading. We've got y equals 1, which would be this. We've got y equals 4, which is this. This is y equals 4, y equals 1. And then we've got the line x equals -4. Okay, x equals -4 is vertical. And we are rotating it around that. Okay, so that difference is normally we would be rotating only around the x or the y axis. Now we're rotating around this line. Now, the good news is the lines that we will rotate around are only going to be horizontal or vertical. Okay, so there's no diagonals, there's no equations, it's just horizontal or vertical. So if we're rotating around this line, remember what I told you the other day was that we always draw our slice perpendicular to the axis that you're rotating around. So here's our slice. Now, first question I have for you. Is this a jelly-filled donut or a donut with a hole?
Jelly donut.
It's a jelly donut because there's no hole, right? How would I know there's no hole?
Because there's no second line that we're looking at.
Okay. Yeah. There's no gap between the thing we're rotating around, which is the x equals -4, and the region that we're rotating. Now, the sneaky thing about this, there's nothing else sneaky about this. The sneaky thing about this is what is the radius? Okay, so here, let's draw our circle. If we were rotating around the y-axis, okay, so listen to my statement. If we were rotating around the y-axis like normal, what would the radius be? It would be x, correct, because we know this is the point, x comma y, the radius is x. It's not x minus 4. It's x plus 4. It's bigger, Joe.
Oh, yeah.
Right? So it's x, like this would be what we're rotating, that would be the normal. We're adding 4 to that radius. So up here, this is x plus 4. That's our radius. Okay. Problem is, I don't have an equation for x at the moment. So y equals e to the x. What's the equation?
Natural log.
Natural log both sides. So x is natural log y. So my radius then is natural log x plus 4
Y,
pi radius squared.
Y plus 4. Yeah, sorry.
Yes, you may. Thank you. For a minute, I thought you were asking me why. Why?
Y.
Okay. From where to where?
-4.
No.
Oh, no, it's 1 to 4.
1 to 4. That's those other two lines there, right?
I'm airball today.
Yeah. This is why we draw the picture. Mister, I don't do good with the pictures.
I am drawing the pictures. I just am not good at the
'Kay.
pictures. That's why I.
We're not going to take the time to plug this into our calculator because you can do that. Okay. I would rather you have the time to do the homework that you're going to get. Okay. So, let's graph this up. Okay. It says, let R be the region enclosed by the y-axis. The line y equals 4. Okay. So y equals 4. And the curve y equals x squared. So my region that we're dealing with is this right here. I would always do this before, like I always draw the region before I worry about what it's being rotated around.
Okay, so why do we just assume that it's the quadrant 1, 1? I mean,
What does this say? It says, fair enough. In this case, it could be the other one. Yeah, I should have said positive. It's that wouldn't mean a difference either. I should have said first quadrant area on this one. Yeah. So we're rotating around this line here. So slice is always perpendicular to what we're rotating around. So the sneaky thing on these, honestly, everything else is normal. The weird thing is figuring out what the radius is. Okay, so is this a donut hole problem?
no.
No, because there's no space up here. This is dx. So the question is, here's what I would say to you. If we were, this is a weird one. If we were rotating this area around, if it went all the way here, no, I can't even give you that analogy. Anybody got a guess on what the radius is?
4.
Okay, the radius is not 4 because it changes, right? The radius is only 4 right here. I can hear you. Hang on. So Austin is saying it's 4 minus the y value.
Yeah, is this like a donut hole problem though, kind of?
No, because you're rotating it around y. You're not rotating it around the x-axis. So there's no donut hole. Okay, so here's what I want you to think about. If you struggle seeing this, I want you to just imagine that this was the point 1, 1, which is a point that's on that curve. Doesn't matter if it is or not. What would the radius be? 3. And how do we get that?
4.
We do 4 minus 1, which is the y value. So 4 minus y is the radius, which Austin said is 4 minus x squared. Okay, from where to where? 0 to what?
4.
Nope. 2. Yeah, right where that intersects. X squared equals 4, my friends. That's 2. Okay, so then we have pi radius squared dx. So the radius is the thing there. Number 3. I just want you to draw it and then tell me what the radius would be. Okay, draw it and tell me what the radius would be. Use your calculator, by the way, because who knows what e to the x minus 1 looks like.
Thank you. Just waiting for permission.
Go ahead to zoom in.
How do I do a line x equals 3?
You don't. You have to draw that yourself.
Okay, thank you. Okay, looks kind of weird.
Make sure you got the right region is all that you're looking at there.
Yep. I still draw the whole thing and then I scratch out the other part.
I would as well.
So I see goes 3 is like past.
That's okay. Looks like this, right?
That's about 3. Mine's more like, I think I think so about more like. Y negative 1. Okay, so there's quite a bit of mumbo going on here. Where's your y negative 1?
I haven't drawn it yet. Working on it.
No, you did that.
I'm working.
Did that intersect in the positive? Oh, that is.
What am I gonna get? How is there a subbar? Oh, I missed subbar.
I heard they're bringing it back after the seniors leave. Somebody told me that.
Yeah. I think as we were talking about, we said that the other day.
Sub-bar.
I hear they're taking away the sauces after we leave.
No
Really?
way.
No.
Dude, they
Actually,
better
I don't
not.
care.
They said that they're using up the old stock of sauces. That's why they think it'll only last until about the time we're gone.
What sauces?
So they have
Garlic
sauces in the
butter.
pizza line.
They already
go back and
Maybe
get
in
them.
a jerk.
Dude, there's no way they're gonna get rid of Chipotle sauce, bro.
They have range sensors out.
Ranch Chipotle, all of their giant dispensers are empty every single time I go during lunch. The ketchup is empty, the mayonnaise, the ranch, everything's empty.
How?
Mayonnaise? I don't know. They're ginormous and there's like 6
There's
of them.
mayonnaise? It's
Okay.
It's on the
So,
back side of the ranch.
First question I have for you. Is this a jelly donut or a donut with a hole? Donut with a hole, which we know because of the gap between our area and our region here and what we're rotating around. Okay, this is dx. Okay, now here's my first slice.
It's a big hole.
It's a big one. There's not much donut there. It's a very disappointing donut. Okay, what's the radius?
X.
Garrett, don't guess.
Okay.
This is x comma y. There's no way the radius is x if we're
Y plus 1.
going this way. It's y plus 1. If we were going to this line, which is the y-axis or the x-axis, the height would be y. It's 1 beyond. It's y though. It's not x. It's y because we are dealing with an up and down.
Which one is the one we're rotating?
The one way down there.
Right.
The bottom one.
Okay.
Y equals -1. Draw your slice vertical to that, parallel. Oh my gosh, vertical to that, perpendicular to that. So your radius is y plus 1. So what would be, we're not going to, like I said, we're not going to math this out, but what would be which one's on the top? Yeah, so it's e to the x minus 1 and then plus 1, so pi radius squared. What's the intersection point? Anybody find it?
It was like 1 or something.
It's 1. Yeah, so it's from 1 to 3 because we end at 3. It's capped at 3. And then the other one, I'm not going to put the dx in there. The other one, his radius, the nice thing is once you decide the radius, it's the same. It's y plus 1. It's just that your equation changes. Your y to be x plus 1. Don't forget to square it because it's pi radius squared. Okay, turn over. Make sure, go ahead and draw this one. Again, see if you can figure out what the radius is. Make sure your calculator is in radian mode though. We didn't actually find the area.
My graph. Why is so mean? there's no way they're gonna take all the way there's fully sauce too. That's like my favorite thing ever.
Garrett, please just math for me.
It's whole time math.
No, you're not.
Well, it says I have to type in the graphs right now so I can just like talk while.
I might be the slowest grapher in the history of the world.
That cannot be right.
Oh my God.
Zoom in.
Zoom in.
Are you in the right mode?
Agree.
No. Come
I
on.
literally just said make sure your calculator's in radian mode.
He was behind on the notes and he was asking me what to put down. I cut him a little slack.
Mister, I can multi-math.
He's just a baby.
I was writing down stuff, not math, I wasn't even talking then. So if you think about it, I'm more focused when I'm talking.
He's literally just a
Shh,
baby.
stop talking.
This is ugly.
That's ugly.
No, my drawing,
Oh.
the graph is ugly, so I have to
Why
start.
is this window? I just want to zoom in right here.
Here. It's good.
I never make my graphs big enough and then they look stupid. Oh wait, you're supposed to find a radius
It is
now.
It's definitely.
Why +2?
Don't guess. We're rotating around an up and down.
Oh.
It can't be Y related.
Okay. That's what I keep messing up. So it's
X equals 2 is whatever you want. So it's no.
Which one do we take out?
It's this little area right here.
Yeah.
So then we do a box thing like this. I don't know what box would be.
This is my favorite topic ever.
Yeah.
Do we define the maximum height, not the intersection for an interval?
Did they intersect
We
at
have to
0?
solve for X.
What? 0?
It actually intersects. If you look at your graph, it intersects at its maximum. That's a good question.
0 and
It was like.
It can't, and they can't do it that way.
It wouldn't be how you do it.
It's not possible to do it that way. There are other ways to draw your slices that you could do it, but it's not, we don't cover them.
top one.
Okay, so,
Which one's the top?
How do I get something in terms of X?
okay, so let's say we're here, right? I was thinking about this while you guys were trying this. I think that what I would do, if you're like, I don't know if I'm minusing Y, if I'm plussing Y, if I'm plussing X, what I'm doing, I would ask yourself, if I took it from here to here, what would be the radius? To the axis, what would be the radius? Rotating around this, if I went all the way to the axis, what would its radius be? Its radius would be 2, right? Its radius would be 2. If this is the point X comma Y, ask yourself, are you increasing it or decreasing it? No. Decreasing, I'm less than 2. So I must be doing either X minus 2 or 2 minus X. It's 2 minus X.
How was that for?
Okay, 2 minus X. Maybe that wasn't helpful.
Make it a little bit shorter.
But then getting so if you have to do like inverse sine,
So listen, if you don't like that, okay, I want you to listen to me, okay? If you're like, I struggle to do this, then I would make up an X value. You know it's X related and be like, okay, if this was an X value of 0.5, what is the radius? 1.5, right? And how did I get that? I did 2 and I subtracted the X value. That's how I usually do it. Okay? Make it real and be like, oh, the radius is 2 minus X. Now, you do have to get x by itself. We will review that here. So if you're trying to get x by itself with this equation, we're not even talking about the other one. What do you have to do?
Inverse sign.
You have to do sine inverse. Yep. So sine inverse. So sine inverse of y equals pi over 2x. Now what?
Times, divide by pi over 2.
Well, let's make life easier and multiply 2 over pi, which is the same as dividing. It's just easier. So this would be your multiplying by the reciprocal, Joe, is what we're doing.
Yeah.
This would be your x. So you'd have to do 2 minus 2 over pi sine inverse of y squared. That's the dy. What?
Pictures just
Pi x over pi x over 2, and then you have pi over 2x.
Pi x over 2. Because it doesn't matter.
I think
Okay,
just
so
the side of it.
pi x over 2. Well, you would multiply by 2 and divide by pi, right? That's what you'd have to do to get x by itself. Multiply by 2, divide by pi. Because it's like x over 1. So I could separate those.
It just looks like it's down there.
Yeah, it's not. It's next to. I got what you're looking
This
at.
is a donut, right?
This is a donut. That's the outer donut. And so the inner donut would be, that's 0 to 1, by the way.
It's the same thing you put in the other equation.
You put in the other equation, which the other equation would be what?
Easier.
Square root of y.
No,
Square root of y. Because you got it, it's x, right? It's 2 minus x.
And do you want us to simplify this, or since we just plug it in our calculator?
No, on earth, heavens on earth, no.
I just meant to simplify the y part, like the one.
You can't because you'd have to expand that.
Yeah.
You can't just add on minus square root y to the other equation.
Okay, I get what you're saying. I understand what you're asking me. So you could rewrite it. Is this what you're asking me, Joe? Like to rewrite it as 1?
That's how I have it.
I would rewrite it as 1 too. It's dy though, it's dy. Okay, last one. I want you to try, let's go all the way through on this one only.
Gotcha.
Okay, I'm looking for the full volume, including the radius.
I'm not gonna draw a picture this time. See if I can get it better. Miss Douglas, I look at these.
Okay, don't draw it. I'm not going to, you do whatever you want to do.
Well, maybe I need more help, but I don't know. When I draw those donuts and stuff, I don't know what this is talking about.
Then don't draw it.
I'm gonna see if it makes a difference. And if I'm like, man, this was even worse, then maybe I'll have to come in and recess or something. If possible.
There's no success till Friday, but sure.
At some
At some point.
There's no success till Friday.
I just said that.
What's Tuesday?
Testing for the underclassmen.
Maybe all of our first hours are longer.
Yep.
Just first hour?
No, all of them. First, second, third.
Oh. It's gonna be the same schedule as it was last week.
Yep.
You just told me to dress up, I was gonna talk to you tomorrow morning.
Yeah, fair enough.
Bro, I'm literally gonna rage. Brutally. Come on! 4 French and just. I'll take No, they told me. They said, Joe, you're a failure. This is how
This is how you win. I like meetings.
Alright, then I gotta imagine this line. It's
Fine.
full of no
It's not
donuts.
close.
Sitting around there.
Zero.
You're such a 0. And great here.
What's the next day?
Is this 4 minutes?
Donut.
Okay. When would it ever be y minus 4?
Upside down?
I'm thinking.
Maybe 4 minus y.
If it was on top of it, if the region was above it.
But it's
So this is like the same one, but the opposite.
Right. Like if you have that same,
Yeah, so move the graph to where the 4 is, and move the 4 to where the 1 is.
so yeah, like if it was here, and we were rotating like something like this around this axis. That would be y minus one.
So.
But if it's negative, then it would be
Plus you're adding on.
y plus that or that plus 1.
Doesn't matter.
Just
Right.
Because it's plus.
To me, this one is the top because we're rotating around.
I
Yep.
just, you're
Okay.
long term, that's the same.
Thank you.
It's the outside, right?
Yeah.
Yep.
I'm sitting right here, and I think, actually, that's pretty good. I don't have any money, what am I talking about?
Mason, you're just not thinking about it.
So we only need to separate the x's and y's, like when it's in terms of y.
Correct. When it's a dy slice, right? With this dy, that's the only time you need to separate them.
I'm not even one test.
You're just thinking.
Yeah, I feel like I can understand it. I just, well, let me rephrase that. I can do the math, I just don't understand what's going on behind the 4 scenes minus when I try to picture this stuff.
4 minus 1 x squared.
It would be really cool.
No, yeah, you're right.
All you.
Miss Douglas, can you tell me that trick where you plug in a value for the radius one more time?
Yep.
What do you-
So like, let's say I don't know. I'm like, can't do it. So let me make up that this point is the point. Don't make them the same. Even if it's not on the graph, who cares, right? Well, let's make this 4, 1.
4 1.
Okay.
Got it.
So what's the radius?
4 to 1
From this 4 to that coordinate point.
to the corner point.
Coordinate point,
3.
right? How did you get that?
Yeah, okay.
Okay. So just plug in a point, right? It doesn't even have to be a reasonable one. Plug in a point and be like, well, I know it's y related. What would the y value be? If the y is 1, radius is 3. I did 4 minus the y value.
Okay.
I kind of feel like I'm just making stuff up and I happen to be right. So, I'm not. It really has to be.
Okay, so first question,
Oh, shoot.
jelly donut or donut hole? Donut hole. There is a big old hole in the middle, right? So outside minus inside. Okay, now what's the radius in terms of x's or like in terms of y's? 4 minus y. Okay, this is also 4 minus y. It's just a different y. Okay, so again, if you're like, hang on, how did you get that? I would come right over here and be like, all right, I think this y is 0.5. Okay, so what would the radius be? It would be 3.5. 3.5, so I would do 4 minus 3.5, that's 4 minus 0.5, so 4 minus the y value. So,
Because, oh yeah.
which one is the outside donut? The curve. So 4 minus 1/3 x squared pi blah, blah, blah squared. And it goes from 0 to 3, right?
Yeah.
0 to 3. And then the other one is going to be 4 minus the line squared, all dx. The sneaky part of this is putting in your calculator, right? Honestly, I got 8.4 pi.
So you know that equation goes first because like it's rotated around the y equals 4. You can like flip your paper upside down.
And so it's outside, right? It's further away from, so it's going to be the bigger one. Mason.
So we kind of like think about it now, because it's not always just the one that's on top goes first.
Correct, because it's the outside, right? The outside of the donut minus the donut hole. Yep.
Okay, that makes sense.
Should make a little more sense.
It's the bigger slice minus the
Bigger slice minus smaller slice.
I understand.
Yep. Okay. So I will shut this off and I'll give you your homework.